introduction of enterprise-grade quantum computers that can revolutionize life sciences, logistics, chemistry, and just about every other industry on the planet. We started decades ago by gathering a group of PhDs who pioneered quantum computing, then used the atom, nature's perfect quantum system, to create flawless, perfect qubits. In doing so, we unlocked unparalleled stability, durability, and quality. After years spent developing groundbreaking quantum technologies to deliver performance, scale, and enterprise-grade solutions, we were able to create quantum systems with a modular, highly connected, flexible architecture to solve complex problems faster and more efficiently. We went on to develop quantum technology that enables unparalleled performance with high qubit quality, fidelity, and gate speeds. We opened America's first dedicated quantum computing manufacturing facility. We designed our quantum computers for interoperability by making them rack-mounted, allowing them to coexist in data centers along with classical high-performance computers. And we engineered these computers so they could be manufactured and transported across the globe. With all these capabilities, the world's most complex and impactful problems will likely be solved. Advances in medicine can explode. Supply chain, energy, cybersecurity, finance, and industry as a whole will potentially be revolutionized. Because with Ionq, quantum is now.
Hello and welcome back to Stacks Talk for the final session today. And this session is called Unhackable by Design, the future of secure global connectivity. And it is brought to you by Ionq Capella Space. So for today, I am joined by Corey McClelland, Ionq's Senior Director of Quantum Networking, and by Capella's Vice President of Constellations and Operations, Constellation Operations, just to be more exact. Sorry about that. Corey, Chris, thank you so much for joining me today.
Great to be here.
Uh-oh. Does Chris
Thank you.
Gehant have a voice? There we go.
I
Good.
do.
You know, earlier today we had a bit of a discussion, right, about quantum. And that was brought to us by the wonderful Joel Mosier, Dr. Mosier of Secured Quantum Services. Thank you so much. And by a couple other gentlemen that explained quantum technology to us. The basics. I wouldn't call it, and he would kill me if I said he explained everything because he's sitting right across from me and giving me that look. But truly, right, he did give us some of the basics of what that is. But what I really wanted to know is what is the quantum future? And for that, I know, Corey, you have a view.
That's an interesting question because it's so diverse and unknown at this point. First of all, I'm Corey McClelland from Ionq. Been in the quantum industry for about 7 years now. Came from industrial control, cybersecurity perspective with Sempra Energy. And the way I found Qubitek, we were looking for an out-of-the-box solution to an energy protective, to protect the electric grid. And what was more out of the box 8 years ago now than a quantum protected network. So that project went on, very successful, California energy system for the 21st century across a number of different areas, but quantum was very interesting. So I ended up leaving Sempra and starting with Qubitek. That was actually 7 years ago yesterday. So what makes the future of quantum unknown is I remember a time before the internet, and nobody knew what the internet was going to do once it came out. Scientists had a better idea than anybody else, but nobody knew that a company like Amazon would be one of the biggest companies in the world in the early 1990s when the internet revolution started. Quantum powered AI is going to change the world beyond anything the internet ever dreamed of doing. And that's in our future, and it's not that far away. Ionq's roadmap now has the possibility of enabling Shor's algorithm in a 2028 timeframe, which brings in Q-Day, when quantum computers can break current security. So there's a lot of change coming up. Quantum computers will enable a lot of that. And so to answer your question, I don't know what's going to happen.
That's a truthful one. Well, then take a moment right now and really introduce, what is Ionq, right? I know it from, looking at stocks and trying to see if there was a quantum company that was publicly traded when I was looking at quantum stocks, right? And there it was, Ionq. And in fact, Ionq is the first publicly traded quantum company, right? But what is it really? Besides something that's got really great videos, which it is really great. I mean, don't get me wrong. But yeah, what does Ionq do? So
Ionq is a full stack quantum company now. It started out as a quantum computing company. Chris Monroe out of University of Maryland came up with quantum gates using ion traps probably 15 plus years ago. And so that was the genesis of the company, focused on quantum computer using ion traps. We've since diversified into quantum networking and into space, and Chris will tell us more about Capella and the integration of quantum onto the Capella bus. But it's a full stack quantum company, and like you said, we're publicly traded on the New York Stock Exchange and have a number of firsts, including the first commercial quantum network at Chattanooga, Tennessee. It's up and running, and that will also have a Forte Enterprise quantum computer tied to it that Ionq is installing right now.
Can you actually take a second and compare like a quantum computer to a classical computer? Because I'm not really sure everyone really gets the magnitude. I mean, they read stories of quantum computing coming out of Alphabet or what have you, and it's faster than something or other and faster than blah, blah, blah. But yeah, what does that, what does that really mean to, let's say, someone sitting right here in the room?
Well, Joel did a great presentation on that this morning.
He did. But just refresh us.
So quantum computers give us exponential power over computers of today. And Joel did a really good description of that and why with superposition and entanglement that is enabled. So every qubit that's added basically doubles the compute power that a quantum computer can access. So some of the intractable problems we have today, take the traveling salesman problem. A quantum computer will be able to solve that, keep our fingers crossed, at some point in the future.
Now, before I let you go and move on to Chris, when we were preparing for this session, you said something to me that really has stuck in my mind. And you said that quantum will, quote, blow the future away. Okay.
Yeah, and we
what do you mean blow it away?
So we talked a little bit about that this morning. Whoever wins the quantum race is going to dominate the world, both from an economic perspective and from a national security perspective. And whoever gets there first will have the first mover advantage. And whoever gets there first, especially as an example, breaking encryption, they're not going to tell anybody. They're just going to start absorbing all the information because they can crack all the codes. So we need to put both our resources, energy, workforce, basically similar to a Manhattan Project with quantum and AI to enable that so we get there first.
All right. Now, Chris, I really want you to introduce Capella Space. Now, I know Capella Space, and I've been following Capella Space for a long time, but not everybody knows Capella Space. Capella Space is very well known here in the Space ISAC because Capella Space is a founding member, right? So, but for the audience on this live stream, yeah, tell us about Capella Space. What does Capella Space do? what is synthetic aperture radar, because that's very key to what Capella Space is, does, and provides to the U.S. government as well as other governments around the world.
Okay, so that's a pretty good sized list. I'll see if I can work through the whole list. So
Well, only if we count country by country, right?
right. So to start off, my name is Chris Gehant. I'm Capella's Vice President for Constellation Operations. So at Capella, I'm responsible for all of the ground software that's used to fly our spacecraft, as well as all of the operations teams that execute that software for conducting all of our anomaly operations, our nominal operations, mission operations, and launch and commissioning exercises. So my area of expertise is in ground architectures and ground execution, and my history is in position navigation and timing, satellite communications, as well as Earth observation. So all those different types of architectures are ones that I've designed and fielded in the past. So for Capella Space now, Capella Space has been around since 2017. We are an organization of about 250 individuals that has design and build capacity for our bus, our payload, and all of the ground software. So we are a vertically integrated full stack provider of SAR imagery. So SAR stands for Synthetic Aperture Radar. Okay. We have been in the business of providing 24/7 automated mission operations now for SAR imagery since 2021. So 4 years for fully automated operations. So you might ask, what is SAR imagery? So SAR imagery is a capability that instead of using a telescope to take a picture of the Earth, it uses radar to bounce radar waves off of the Earth and then receive that back at the satellite, allowing you to take very, very accurate millimeter level readings of the position of all of the elements within the array of field of view. So what that allows you to do is some really interesting things. So the first is the radar frequency that we broadcast in can see through certain materials. So if you have, say, a piece of equipment that you're hiding from an optical telescope under a tarp, that doesn't do anything from a SAR imagery perspective. It can see directly through those tarps, and it can see what the device is that's hidden from an optical telescope array. Another thing that's very interesting about SAR imagery is that it doesn't require light for you to be able to resolve the image. So that means you can take imagery at night. It's also not susceptible to issues like cloud cover. So if you need imagery done and you need to get the results no matter what time of day or night and no matter what the weather is, SAR imagery can do this. And then the last one I want to bring up is that beyond day or night, that millimeter level deformation modeling lets you record information over time about exactly the position of different elements. So for example, we've had issues where the
dam.
Yeah.
There you
So
go.
at the Mosul Dam in Iraq, we're able to take imagery over that particular substructure over time and determine that there were structural deformities within that dam and allowed us to identify for the engineers how to avert a critical failure of that dam. We're also able to do things like, crazily enough, monitor roads and determine if there's been troop movement over a road at a period of time because it has such a fine grain level of accuracy, you can tell if a heavy piece of equipment has been driven over that particular location.
And didn't Capella also provide us with imagery that confirmed that Russia sent tanks across the border from Belarus into Ukraine? And it was a big deal because
Correct.
it was a cloudy day, right? It was in February. February is really cloudy. It's rainy. It's cold. It's mucky. It's yucky. And you just, I mean, you couldn't see it with the regular optical.
That's
device.
correct. That's an example of the day or night operations and the weather-independent operations. There are certain regions of the world that are routinely in a cloudy space where you just can't take imagery of them. So Capella was, I think, the very first commercial organization to detect the troop movement into Belarus from the invasion of the Ukraine for that reason.
And how many satellites does Capella have?
So Capella currently has a satellite constellation of 6 SVs. We have 2 more that are launching in January, with a 3rd launching in February of next year.
Okay, so now Ionq, you're now a space company. And if you don't know this, you should, because Ionq actually closed on a deal with Capella Space for $310 million, mostly a stock play, if I'm not mistaken. Excuse me. And yeah, that closed about 7+ weeks ago. Not at quite 8, but getting there close, right? So what is the space play for Ionq? Why buy into space? I mean, you were doing fine. You're shipping computers around the world, so why get involved in space?
Very interesting question. So back when I was at Cubatech, we had a Army contract to harden our equipment for launch and space operations. So we had a vision of a quantum network in space about almost 2 years ago now. We actually used Aerospace Corporation to help us get all that certification done. It was a very interesting project. We met a bunch of people in the space industry because of that. And as we started to talk with Ionq about purchasing Cubatech, that was one of the pushes that we had. That not only was it terrestrial networks, but it was also space networks, and you really needed to look at quantum networking as a whole. And so pushing into space is going to be really important. If you think of a quantum network on the ground, we have certain limitations, the distance, et cetera. But in space, we don't have those because we're using optical free space communications as opposed to fiber on the ground.
And optical free communications is?
Optical free space is basically using optical terminals for both downlink and uplink.
So that's laser communications?
Similar to laser communications, just a little different.
Okay, just wanted to, make the delineation so that all of us can, follow along with you. But yeah, what do you want to do though with space? I mean, so Cubatech wanted into space. Cubatech was also acquired by Ionq, right? I don't know how much the deal was for, but it was also acquired, so bought into the idea of space. What does Ionq want with space?
So there's a couple of plays. One is security, to utilize quantum entanglement key distribution in a constellation to allow for secure communications of the SAR data to go back and forth. But in the future, we're also looking at other applications utilizing entanglement, which brings in alternate PNT, synchronized timing down to the picosecond level, and other applications that even today we don't know what they'll be.
And you can only do that in space?
Well, space enables so much more because of what we're looking at as far as the coverage of the Earth. So if you looked at the ARPANET when it started, it was node by node on the ground, tying together what became the internet, which today is ubiquitous across the world. With quantum, it's going to be the same way. We're going to be doing quantum nodes from site to site, but the communication is going to be slower by utilizing satellites. We're going to be able to span the distance a lot faster. We're going to get to a full worldwide network, quantum network faster.
Let me pose this question to you, though. Let me just tease this out just a wee bit more. Isn't there also, not just in terms of security of your communications, but there have been quite a few stories, I would say, in the past 12 months where we have undersea cables, the fiber optic cables being cut, right? I mean, if you own the thing that is actually communicating and nobody's dragging their anchor across an orbit, doesn't that give you more resiliency, more dependability?
It does. It really helps with the overall resiliency of a network. And to be clear, on the internet side, the quantum-enabled internet will not be like today's internet. It'll be very specialized for quantum applications. So you won't be doing transactions to buy something on a quantum internet. It'll be very specific, allowing quantum computers to talk to each other and communicate back and forth.
All right. So, Chris, then, how will Capella make use of quantum technologies, right? I mean, it's an Earth observation company with 6 satellites. What are you doing with this stuff?
Sure. So there's a couple of places where quantum technologies can be used to enable better capabilities from a SAR perspective. So to start off with, secure communication of data from the space vehicles to the customer that's requesting the data. As we approach Q-Day, secure communications are going to become very, very important in a quantum-enabled world. So Capella is going to be the first Earth observation company with quantum secure communications of important data to customers that can't be intercepted and can't be broken through an encryption device, right? So that's number one, is the security. The second thing to consider is that there's going to be applications for position navigation and timing from quantum technology, where you can get much, much more accuracy, but more important, you have the ability to do PNT missions where they are not subject to RFI, which is radio frequency interference. Well, that's a big, big impact to a space constellation that needs to know exactly where it is in order to take measurements from the space vehicle to the ground and back again. The largest source of error in a SAR imagery constellation is from not having very, very accurate understanding of where your space vehicle is over time. So there's certain regions of the Earth that when you pass over them, we're experiencing enhanced levels of RFI. If we aren't subject to the RFI, now suddenly our imagery in those regions is much, much more accurate and much, much more clear. But the biggest thing, and the thing that's most interesting, though, it is beyond just the enhancements to our SAR capability we have now. Capella intends to take our current constellation size of 6 vehicles, growing up to 9, and growing that out to become a proliferated LEO constellation with dozens, hundreds of satellites over time. So in this way, we intend to leverage our capability of building buses and technology with a very tight 15-month design cycle, and our build cadence, which currently is at 6 satellites a year and is growing to 12 satellites per year. And we want to enable that to be able to field test technologies from Ionq in space, to be able to show that we can field systems that are doing the transmittal of quantum entangled particles from one location to another, to be able to show that we can take quantum memory and field that in space and be able to hold a quantum entangled particle in that memory storage device for later delivery to another location on the ground. But even more exciting, though, is the idea that when you're talking about a quantum network, okay, it can only travel, as Corey said, so far along the ground before you have loss of that data through the fiber optic cable. And it's only about 400 kilometers. So if you're talking about being able to do transoceanic communications, like we were talking about earlier, you have to deploy thousands of repeater stations across the ocean floor, and you have to keep them operational over that period of time. This is something that's going to take decades.
And keep them safe from adversaries from dragging their anchor.
Yes. So what that means is that for long-distance communication, for able to link a campus to another campus, a government institution to another government institution, you can't rely on having long-haul fiber optic cables to achieve that mission. What you're going to need is the ability to communicate entangled particles through space communication links down to your next location on the ground. And that's something that Capella Space is going to enable for Ionq.
Would you need repeaters in space, though? Because, I mean, 400 kilometers is 400 kilometers wherever you are, right?
Right. So no, you don't need repeaters in space. And the reason why is because when you're in free space, you don't have the atmosphere or a fiber optic cable that's causing degradation of the signal. As long as you have line of sight in space, you can communicate through laser comms, and you can transmit that entangled particle from one location in space to the next until eventually you can drop down to the ground at a ground station as a optical enabled terminal.
Something that also kind of struck me about the deal, right, about the acquisition and about quantum and about the product development and capabilities, is that when you speak with your government customers, right, and, you know, it had to be blessed off by the U.S. government. There was a time period when people could make comments or organizations could make comments, agencies, et cetera, et cetera. But I kind of wonder, you know, what do you tell your government customers about what you're doing? Like, what problem do they have that this will solve?
So I can start with this one. So obviously, the one that everyone knows about from a quantum computing perspective is the ability for the quantum computing power, right, for the ability to process through problems so much quicker than a standard computer can, is going to break our standard equation, right? So the first thing everyone talks about is security, and we talk about government security all the time with customers. But the thing that I think that is more interesting, and the thing I'm excited about talking about, is the ability for quantum entangled particles and being able to distribute those quantum entangled particles between quantum processing facilities enables global scale distributed quantum processing. And that's a pretty big deal. Right now, our computer infrastructure, as you know, has large-scale computer farms, right? They are distributed across the globe in various locations, and they are linked by fast fiber optic cables for them to communicate data back and forth. There's an equivalent of that on the quantum side, where you can do the same thing, except for standard fiber optic communications between those nodes isn't sufficient to achieve that distributed quantum computing capability. What you need is for each of these quantum computing facilities to have a collection of entangled particles that are distributed across the other nodes within the network to allow them to coordinate their processing capabilities.
Just for my brain, right? I'm not a physicist, and Joe will probably tutor me if I pay him enough. But could I conceive of this as being like cloud computing? Is that what you're talking about? That kind of power, and that the computing that computing power could be available wherever?
Yes. So, and beyond just cloud computing, if you have a collection of quantum computing nodes that are linked together, you are not limited then by the qubit processing capability of the single location. You can combine several together. So when you think about Q-Day, which is rapidly arriving, what we're really talking about is how many qubits of processing power can we assemble into a single computing platform to be able to break that encryption model. Well, if you aren't reliant on a single computer, if you can take a host of computers that are now linked together from various geographic distributed areas
Through space.
Which is required. You have to be able to transmit through space to be able to get all these things linked together. Now what you have is the ability to field a collection of smaller facilities, but together represent one large computing platform. It's a huge accelerator.
All right. So guys, right, we've got a quantum company that has bought a space company, right? In the process of merging, what are the capability couplings that you can see like right away? Like what could we see in the next 12 months? Because a lot of the things that you're talking about are, well, kind of a few years out, right? But yeah, what's gonna be the first thing? What's gonna be the second thing? That you guys are actually, merging these capabilities as you are one entity now.
So initially, we just need to start testing and getting our quantum equipment enabled on Capella satellites. That process right now, we're looking at about 18 months to get it to the point where it's ready for launch and for our first testing. We're going to be doing a lot of ground testing before then to make sure that everything works and as engineered and designed. But after the 18-month period, then we're looking at a 15-month cycle for new innovation for the Capella satellites and the Ionq quantum technology. We're also, longer term, looking at getting quantum computers in space. So not only will they be on data centers on the ground, but we want to get them up in space as well. We just are in the process of acquiring a company called Oxford Ionics, which is going to increase our quantum computing capability by about 50 times over what our current capabilities are, and that's the roadmap that increases us to get the number of logical and physical qubits in the 27-28 timeframe that will enable Shor's algorithm. So those three acquisitions will make us a powerhouse in quantum computing and in the space area.
And to add on to that, you can talk about why Capella, why not some other space organization? So like Corey mentioned, we have a 15-month design cycle, right? And we're going to be moving up towards monthly launches. So you need that kind of rapid development capability in order to space certify equipment. Other things that I think are interesting about that, though, is that for Capella Space, we're going to be launching our first optical telescope for optical comms in February. Cubitech has equipment that's already space certified that we can get hosted onto our platforms and launched into space there as well. I had one other point and I forgot it, so I'll go ahead and pass it back to you.
So one of the other things about ion trap computing is the energy consumption. So we don't need to get our computers down to near Kelvin to do the computing. We basically can plug it into the wall room temperatures for our computers to work, which will be an advantage for the amount of swap that we need when we launch satellites.
And swap is, just for the general audience?
Size, weight, and power.
Thank
yes,
you.
And that was the last point that I forgot to mention earlier, is that one of the things that's very interesting about SAR imagery is that it's incredibly power hungry. Across all the various space missions, it's one of the ones that uses the most power. So we have satellite buses that are specifically designed for that particular mission, which means that our ability to host very, very power-intensive payloads is something that our buses already support, and it'll be leveraged very handily when we start equipping them with Ionq technology.
All right, so get out your crystal balls, guys. Because, well, first of all, this is not going to be the one and only Stack Stock, right? But I do want to know, if I get you two together and we get a couple of beers 5 years from now, right? What are we going to be talking about? Right? What is actually the frontier? Because you're talking about stuff that you kind of already know about, right? So what are we going to be talking about in 5 years?
Well, I'll just keep talking about my lifeguard stories.
But what?
My lifeguard stories.
Oh,
Those
yeah,
are-
okay.
those are
Well, you
universal.
do the
Those go on
lifeguard
and on.
stories, I'll do the war stories. But no, I mean, when it comes to quantum and space systems, what is going to be the frontier then? Where are we going?
Well, in 5 years, I hope that we have a quantum computer in space, that the amount of front-end computing that we're doing limits the amount of data that we need to transfer back to the Earth data centers. Any ideas?
Sure. So from a SAR imagery perspective, as we look into the future, where you're going to start seeing from Capella is beyond, like I mentioned earlier, secure delivery of data products to customers. In addition to that, you're going to see lower and lower service level agreements that reduce the amount of time from the image being taken from space to its delivery as we build out more and more ground capabilities for the satellites. So you're going to see 1 hour SLAs where an hour after you've taken the image, you can receive it. And that's also enabled by being able to do processing on the spacecraft. So where you're going to start seeing then from a SAR perspective is tipping and queuing being handled not from the ground, but from the space, where you have the ability to identify an object of interest in a region and have then an automatic communication from one spacecraft to the next to take repeat imagery over that location so you can now track changes in a region over a period of time. That type of advanced tipping and queuing is something you're going to start seeing from an imagery perspective from Capella. And then when we talk about Ionq and quantum computing, like Corey mentioned, having the quantum processing in space starts getting very, very interesting then, because that means that you can now take advantage of a proliferated LEO constellation that has quantum processing in space as well as quantum processing on the ground.
And lastly, I want to leave everybody with a bit of a thought. We're sort of talking here as if, hey, we all have this in the bag, right? That we're going to be leading the world in quantum and space technology and marrying them up. But, China's all over this, right? They've already demonstrated some quantum capabilities in space, right? So if you could ask for something from the viewers from this room, what would it be?
I think what we're seeing is from governments, China has outspent all the other governments combined today on quantum.
And why would that be? Like, what's their plan for that?
They're incredibly focused on quantum and AI. So they also lead all the other countries in the world on the number of patents that they've put forth. So we have some catch up to do. When we look at the amount of commercial money going in on top of government money, we start to get a little bit closer As an example, in the last couple of months, there's been deals announced, in the multi-billion-dollar range with Capella, Oxford Ionics, Quantinium, Inflection just announced one in the last couple of days. So there's more and more commercial momentum going forward, but we do need a whole of government looking at it instead of separating and diversifying the investments.
Anything to add to that, Chris?
Yeah, we can't afford to move at the speed of government for this. From a national security perspective, we need to be able to unlock the potential of the commercial markets to be able to accelerate our advancement into quantum technologies in order to catch up to China, frankly. That's where we're at. Now, the thing that's really positive about that outlook, though, is that there's a tremendous amount of power in our capital markets to be able to fund the research and development, fund the delivery of space vehicles, fund the advancement of capabilities in these quantum companies, right? And in addition, I think the technology platform that we're working from, particularly at Ionq, is very, very strong, with a lot of places where it has unique advantages that can't be competed with. For example, the ability to do quantum operations without having to cool the chip down to 0 degrees. We have the ability to do room temperature computation cycles. So I think that the urgency is real, but the capability is there for us to be able to catch.
Corey, Chris, thank you both so much for making the time to come on Stacks Talk. And everybody, please give it up for Corey and Chris. Now, that's the end. Oh, and Aaron has made it. Fantastic. Good. Oh, and we are going to play a video first? All right, we're going to play a quick video.
Exactly when does the future start? At what point do ideas become reality? History tells us over and over that the future begins with a whisper, not a shout. Only those listening the most intently can hear it. And for quantum computing and networking, that future is now. Because Ionq has taken quantum from the lab to manufacturing and into the real world with the international introduction of enterprise-grade quantum computers that can revolutionize life sciences, logistics, chemistry, and just about every other industry on the planet. We started decades ago by gathering a group of PhDs who pioneered quantum computing, then used the atom, nature's perfect quantum system, to create flawless, perfect qubits. In doing so, we unlocked unparalleled stability, durability, and quality. After years spent developing groundbreaking quantum technologies to deliver performance, scale, and enterprise-grade solutions, we were able to create quantum systems with a modular, highly connected, flexible architecture to solve complex problems faster and more efficiently. We went on to develop quantum technology that enables unparalleled performance with high qubit quality, fidelity, and gate speeds. We opened America's first dedicated quantum computing manufacturing facility. We designed our quantum computers for interoperability by making them rack-mounted, allowing them to coexist in data centers along with classical high-performance computers. And we engineered these computers so they could be manufactured and transported across the globe. With all these capabilities, the world's most complex and impactful problems will likely be solved. Advances in medicine can explode. Supply chain, energy, cybersecurity, finance, and industry as a whole will potentially be revolutionized. Because with Ionq, quantum is now.